Television has become one of the basic necessities of every household. It is an indispensable part of modern culture. Since the arrival of music videos, we have relied on television to provide entertainment, news, education, culture, weather, sports, and even music. Because of its ability to create powerful touchstones, television enables young people to share cultural experiences with others. Which brings us to an important question. How is a television made? Hi guys, welcome to another exciting video from our channel. How's it made? Before jumping into the video where we show you how the televisions are made, if you're new here, please consider subscribing to our channel. Also hit the bell icon to get a notification whenever we upload a new video. That said, let's begin. History of television. The development of TV has gone through many years and is widely used in many countries, including electricity, mechanical engineering, electromagnetics, sound technology, and electrochemistry. No one invented television. On the contrary, it is a combining of inventions perfected by fierce competition. The chemical substance as an electrical conductor was one of the first discoveries that led to television. The Swedish Baron Hans Berzelius separated selenium in 1817, and Louis May of the United Kingdom discovered in 1873 that the element is a strong electric conductor. It was no one but Sir William Crookes who invented the cathode ray tube in 1878, but it demanded many years for these greatest results to be consolidated into the mutual denominator of television. Whereas in 1884, Paul Nipkow, the German technician, made the first original television. To be precise, his mechanical system uses a scan disc with small holes to pick up image fragments and print them on the photosensitive selenium tube. Years later, nearly in 1888, W. Hallwachs applied photovoltaic cells to cameras. Boris Rosing of Russia and A. Campbell Swinton of the United Kingdom worked independently in 1907 to prove that cathode rays are a device that resembles images on the receiver. Countless radio pioneers, including Thomas Edison, invented the method of broadcasting television signals. In the 1920s, John Logie Baird of Scotland and Charles F. Jenkins of the United States built the first real televisions by combining Nipkow's mechanical scan disc with vacuum tube amplifiers and photovoltaic cells. The 1920s was a crucial decade for the development of television because many large companies, including General Electric or GE, Radio Corporation of America or RCA, Westinghouse, and AT&T began to study television seriously. As a result, by consideration in 1935, the mechanical system then used for transmitting black and white images was entirely replaced by electronic methods. These new replacements were capable of generating hundreds of horizontal bands at a rate of 30 frames per second, and it was Vladimir K. Zworykin, a Russian immigrant, who helped with the replacement about the same. Speaking of the implementation, he first worked at Westinghouse and then at RCA. He applied for a patent for an electronic camera tube based on a cathode tube. Philo T. Farnsworth and Alan B. Dumont, both Americans, developed a pickup tube, which in 1939 became a home TV receiver. By then, the Columbia Broadcasting System, or CBS, has entered the field of color television and competed with RCA for complete color television, initially using mechanical methods until a fully electronic color system could be developed. Although both World War II and the Korean War slowed progress, rival broadcasts appeared throughout the 1940s. On June 25, 1951, the first CBS color broadcast aired Ed Sullivan and other stars of the network. By 1954, the United States had begun commercial color television broadcasting. TV design. The design of TV requires the input and teamwork of a series of design engineers: audio, video, plastic, and optical fiber. To be precise, the optical and electronic engineers are completely connected in conceptualizing the new TV design, and also the technical and sales functions that decide its selling point. Hence, a brand new TV design may have one or more new technological applications as a feature. Well, it might be just a different size from an existing model, or it may include a series of new features such as an improved sound system, a remote control. The remote control device was a must thing and was very necessary because remotes were the only device that can command other entertainment devices. On the other hand, speaking of the actual conceptual plan for the new series, it was then developed by the engineering team. The concept may be changed and redrawn multiple times before the design is initially approved for manufacturing. Then engineering experts select and design the components of the device and make prototypes to prove the design. However, the prototype is indispensable, not only used to confirm the design, appearance, and function of the kit, but also used by production engineers to determine the production process, processing, tools, robots, and modifications to the existing factory production line must also be designed or modified to adapt to the proposal new design. Precisely when the prototype passes rigorous review and is approved for manufacturing by management, detailed plans and specifications for model design and production will be produced. As a result, then you can order raw materials and components made by others. You can build and test the production line, and the first batch can start off the assembly line. The manufacturing process of television. Stating facts, almost all TV housings are made by an injection molding process, which uses precision molds and injects liquid plastic under high pressure to fill the molds. To be precise, all of these parts are removed from the mold, trimmed and cleaned, and then assembled to complete the shell. Whereas the design of the mold makes the brackets and supports of various components become part of the shell. Making of the picture tube. A television picture tube or cathode ray tube is made of precision glass, and its shape has a slightly curved plate on the front or on the screen. It's also possible to add a dark color to the panel glass, either during the glass production process or directly applied to the inside of the screen. A darker panel can improve image contrast. Well, the television chemicals can be deposited on the inside of the panel, and then a thin aluminum film is covered on the coating to allow electrons to pass through. Aluminum is used as a mirror to prevent light from being reflected back into the tube. The number of high-quality glass required for picture tubes is limited, and the emergence of large screens has caused a shortage in this part of the industry. Large screens are also heavy, so flat panel displays using plasma, addressable liquid crystal displays were developed in the 1980s, whereas this gas plasma technology uses electrodes to excite the neon or magnesium oxide layer, so they emit ultraviolet radiation, which activates the phosphor on the back of the TV screen. Because the gas is trapped in the thin layer, the screen can also become thin light. Projection TVs use digital micro-mirror devices to project images. A shadow mask with 200,000 holes is behind the phosphor screen. These holes are precision machined to align the colors of the 3 electron beams. The shadow mask of the best picture tube today is made of a nickel-iron alloy called Invar. The poorer quality suits have iron masks. The reason behind using the alloy tube is because the tube enables the set to work at higher temperatures without worsening the picture quality, and the same way the higher temperature supports brighter pictures very well. The phosphor coating inside the tube is also added with rare earth elements to improve brightness. The electrons are fired by 3 tubular metal electron guns, which are carefully mounted on the neck or narrow end of the tube. After completing the previous step, the electron gun is properly placed into the tube, and with time, the picture tube is relocated close to the vacuum. Relocating the picture tube enables the air to not interfere with the movement of electrons and prevents unwanted harm. A small opening at the back of the tube is sealed with an installed electrical plug, which will be located near the back of the device. A deflection system composed of several electronic magnetic coils is installed on the outside of the neck of the picture tube. The coil generates high-voltage pulses to guide the scanning electron beam in the correct direction and speed. The sound system of television. The enclosure also contains accessories for speakers, wiring, and other parts of the audio system. Speaking of setting the speaker system, it's normally produced by professional manufacturers, keeping in mind the altered specifications of the TV. Hence, they have assembled in TV sets as components or subcomponents accordingly. Electronic sound controls and integrated circuits are assembled in a collective panel as they move along the assembly line. The electrons are emitted by 3 tubular metal electron guns located at the neck or narrow end of the kinescope. After the relocating part is completed, a color selection filter with 200,000 holes is located directly behind the TV screen. Stating the reason, these holes are accurately machined to regulate the colors transmitted by the 3 electron beams. Making of electronic parts of television. When the picture tube and audio speakers and the accessories are assembled in the kit, other electronic components will be added to the back of the kit. While the antennas, cable jacks, other input and output jacks, electronic equipment for receiving remote control signals, and other equipment are prepared by professional contractors or as subcomponents elsewhere on the assembly line, then install them in the device and close the casing. That's it, guys. Let's know if you found this video informative in the comment section below. Also, if you enjoyed the video, give it a thumbs up and share it with your friends, and don't forget to subscribe to our channel for more informative videos. See you in the next one.